All right, thank you all for joining us today. All about VRF, new products, and upcoming refrigerant transition. By a raise of hands, I know we got a packed crowd here. Who here is familiar or has experience with VRF systems? Okay. What about AC mini splits or heat pumps? Same. Great. All right, so he already introduced myself. So, that's what I do. Think of me as a local factory support guy for Central Florida for Mitsubishi Electric. So Mitsubishi Electric makes the mini splits and VRF systems, heat pumps, and essentially we sell through distribution, Trane or other legacy distributor partners. Fun fact, I'm a dual citizen. Like you said, I was born and raised in Brazil, but been here most of my life, so I'm an American citizen as well. And another fun fact, today's my birthday. Not even kidding, I'm 34 today, so nothing better than being here at FLAPA with you guys. So we'll get through this quick, but this is a very pivotal point in our industry in the HVAC side. There's some upcoming changes here over the next couple of years, and it's a big point, a big turning point for what we do. So to get started, the commercial HVAC retrofit and new construction market is expected to grow by about $8.5 billion through 2028. And VRF and heat pump inverter technology will have a big slice of this growth with the push to reduce greenhouse gases. Heat pumps have hit the mainstream. New York Times article back in 2022 showed that heat pumps have outsold gas furnaces in the U.S. in both 2022 and now 2023. This graph only shows through 2022, but I believe heat pumps has also outsold gas furnaces in 2023, and we expect that trend to continue for the many years to come. So that was a major milestone in 2022 for all electric heat pumps, increasingly getting more attention and adoption across our nation. So very, very exciting times to be in the heat pump world of things. All right, so what does electrification, decarbonization, and greenhouse gas reductions have in common? Buzzwords. Everybody's talking about it in the industry. If you're talking about it from a macro level, electrification, decarbonization kind of go hand in hand, right? So that's what I'm going to talk a little bit about here and how that's important with just Mitsubishi, not just Mitsubishi Electric, but for the overall HVAC industry and construction industry on the commercial side. So what is electrification? Regardless of where you stand, on the politics of the topic, these pictures basically show what electrification is all about, right? The decommissioning of fossil fuel power plants to commercial buildings, adding solar panels. The one on the top right there shows a nice, Mitsubishi heat pump on the roof. And then vehicles and various equipment are all becoming battery powered, right? So electrification is viewed as a vital component of the plan to reduce greenhouse gas emissions. HVAC for commercial businesses and residential homes will eventually be converted to fossil-free electric heat pumps. We're already starting to see some of these trends in other states. Heat pumps historically not been very popular in Florida for obvious reasons, right? Where we're primarily cooling only, depending where you are in Florida. But if you're in North Florida, heat pumps might make some sense, right? It's a growing trend across the rest of the U.S. This is a 2023 article from Engineered Systems magazine that covers the decarbonization of buildings using commercial-grade heat pumps. Some of the key items highlighted here: buildings account for nearly 40% of global greenhouse gas emissions, 75% of which result from daily operations. HVAC is a major contributor of commercial building energy use, and heat pumps are recognized as key technologies that unite some of these pillars of decarbonization. So, shifting on-site fossil fuel combustion to superior efficiency of electric heat pumps, heating systems can utilize increasingly low electricity to significantly reduce carbon emissions. And heat pump technology has evolved, and new innovations within heat pump technologies has expanded over the past few years. And we like to think that Mitsubishi Electric has been one of the leaders in that development as well. So in conjunction with decarbonization and electrification, There's a 2022 Inflation Reduction Act, the IRA Act, is the largest ever climate investment by the federal government in American history, projected to reduce greenhouse gas up to 40% below the 2005 levels by the year 2030. The IRA also recognizes the key roles of highly efficient variable capacity heat pumps in slashing domestic greenhouse gas emissions and lowering energy costs for Americans. So another chart here regarding the IRA, Inflation Reduction Act. It plans to inject up to $79 billion in the clean energy sectors, along with the Infrastructure Investment and Jobs Act and the CHIPS and Science Act in the years 2022 through 2027. So this will hopefully allow building owners to retrofit high greenhouse gas emitting buildings, so existing buildings, to low emitting greenhouse gas buildings nationwide. This chart on the right shows the U.S. greenhouse gas emissions from 2005 and projects that those greenhouse gas emissions out to 2030. The IRA is a huge piece of the puzzle that will help us reach our target emissions levels by 2030. But there's still work needed for 50% reduction, as you can see there towards the bottom of the graph. So you might be thinking, how can Mitsubishi Electric Trane HVAC products help? Well, let's shift gears a little bit, and we can start with, our customers have made it clear that they believe our HVAC systems are extremely reliable and have the highest owner satisfaction rating. This is per a Consumer Reports magazine survey issued a few years ago. They surveyed about 18,000 owners regarding the cost reliability of central AC systems. And here are the results. You can see that both Mitsubishi and Trane HVAC equipment are at the top on both owner satisfaction and predictive reliability. To build on that, our corporate commitment and vision is clear: to align personal comfort with the greater societal good, and that aligns nicely with a pathway to decarbonization and electrification. So electrification is part of that equation, right? Between energy efficiency, renewable electricity, and electrification equals pathway to decarbonization. So personal comfort, this is our version of personal comfort. It's a zoned or room-by-room control in comfort using all-electric heat pumps. So you can see here on the left, conventional systems, typically packaged rooftop unit or just one single system for the entire house or building. Our version of that uses individual heat pumps or a zoned system, a multi-zone system, to individually control those temperatures. So what makes our heat pumps efficient? Well, you can see here on the left, conventional systems again, and then our systems on the right. Mitsubishi all-electric heat pumps are up to 40% more efficient compared to conventional split systems. This is large in part due to our variable speed compressors, our inverter-driven compressors. And this applies across the board between all of our mini splits, heat pumps, multi-zone systems, and VRF systems. All right. We'll get into some of the different styles here soon. You can also turn our systems on or off when they're not in use. So you save energy and money on your utility bill. Right? As you can see, a conventional system basically is an on-off constantly, right, depending on the demand in the space. Our systems are designed for optimum control, so it basically varies the frequency of that compressor to maintain the temperature in the space. Thus, minimum energy usage. So you can see there the chart, the compressor power is in blue, temperature in the room is in red, and then the thermostat setting is at 72 degrees across the way there. Okay, so with that, here's a quick overview of our different indoor unit styles. Wall mount is our least expensive and most popular indoor unit style. Great for different types of applications. Typically on the commercial side, you'll see these in electrical rooms, data closets, things like that. We also have a multi-positional air handler. It's really made for the American architecture, right? Put it in the closet adjacent to the room that it serves or wing that it serves. But it is the most costly unit that we make if you look at it dollars per ton wise. We also have our horizontal ducted. So in addition to the multi-position air handler, which is also ducted, this is another version of it. It's just more of a horizontal ducted above the ceiling, so it can be hidden above a ceiling. Great for larger spaces where you got linear diffusers or just regular four-way diffusers on the ceiling, like a lobby or an office or amenity area. And then we have our ductless four-way cassette. Low installation cost, great for an office building, office space, an amenity area lobby, just like the horizontal ducted previously shown. And then we also have our floor-mounted indoor unit, ideal for below the window type application in an existing building. It comes with or without a cover. If you want to, maybe if you're replacing like a radiator, we don't have radiators in Florida, but up north, we do? We do? Maybe in Gainesville, haven't seen too many of them. UF has them? So maybe a radiator replacement at UF, right? If you got those below a window, these are great for replacing that below a window. Maybe you got custom cabinetry or something that, cover the radiator. That's when you use the one without the cover. And then we have also our ductless one-way cassette, great for, along the window line, and also between 16-inch joists in the ceiling for like a home or multifamily. I like to think of the one-way cassette, going back to that picture, it's just basically a ceiling-mounted wall mount. So you got the wall mount with the one-way discharge and return is on the top. This is just that, but in a ceiling, right? All right, so now let's look at our different types of all-electric heat pump systems. Starting off with our one-to-one mini split. This is essentially our bread and butter, right, at Mitsubishi. We brought this over to the U.S. market back in the late 1980s. Ideal for single-family residential applications. Maybe your sunroom here in Florida, up north, maybe in your basement. Basements in Gainesville too? Some, all right. Or in the commercial application side, a single zone like an electrical data closet type of application. Or if you got a cold and hot spot in an office building, it's great for that one-to-one. So you got your liquid and gas line, right, running from the outdoor unit or condensing unit to your wall mount indoor unit. And then you have your power. So the outdoor unit powers the indoor unit in this case, and that's the green line there. Next up is Smart Multi. Smart Multi is the lineup for our multi-zone mini split systems. And it starts at 2 tons all the way up to 10 tons now. So we just added a 6, 8, and 10 ton Smart Multi or multi-zone condensing unit. So you can tie multiple indoor units. In this particular case with the branch box, you can have up to 8 indoor units connected to 1 outdoor unit. There is no option for simultaneous heating and cooling with this system. All the zones are either in heating mode at the same time or cooling mode, as you can see here in this graphic. Next one is City Multi. City Multi is our lineup for our commercial VRF heat pump systems, all right, with the option for simultaneous cooling and heating. And that is through our BC controller, or essentially our heat recovery box, right? We call it BC controller, other manufacturers call it different things, but it's essentially that heat recovery box. It has the capability of connecting up to 50 VRF indoor units or zones off of the same outdoor unit. Currently, they start at 6 tons and go up to 36 tons. However, the average VRF system size is less than 20 tons. Our sweet spot is roughly a 10 ton, 10, 12 ton. That's an ideal size to start with. All right, so what system type you choose depends on the size and height of your building, as well as the number of zones. Here's a quick summary, right? We kind of different building heights here. Single zone, right? That can be multi-story, but then we have low-rise building, mid-rise building, and high-rise building. Typically low-rise, depending where you are in the U.S., that's considered 4 stories or less. Mid-rise could be your 5 to 9 story, and then high-rise is anything 10 stories or above. And that's kind of where we'd like to align our products with. Obviously, City Multi VRF can be applied on a single-story building if it's a big building, commercial building. But if we're talking, larger buildings, maybe a multifamily apartment or something like that, student housing or something along those lines. This is where, from the perspective of vertical separation, how far you can go vertically, this is how we align our products. Okay, so VRF technology has been used around the world since the 1980s. It is the preferred method of heating and cooling in commercial buildings globally. It's been in the US for about 20 years, so we brought our version of VRF back in 2003. Worldwide, popularity is driven by the high cost of energy in modern construction equipment. So as you can see here, Japan, China, 90% of the commercial buildings over there uses VRF. Europe is a little bit lower, but in the 80s. So as you can see, it's very, very common to see VRF systems in commercial buildings overseas. All right, so let's move on to some of the regulatory and refrigerant changes. Any questions before we move on to this regarding our products?
Just, how do you do the outdoor air?
Ventilation? Yeah. We have a few smaller sized outdoor air processing units, but typically no larger than 1,200 CFM of airflow. So if you're truly doing a new construction or a renovation, we typically have a dedicated outdoor air system, like a packaged unit, that kind of handles the latent load of the building. And then VRF is there for the comfort cooling and heating of the building. So here, especially in the southeast in Florida where it's hot and humid, we like to decouple the VRF system from the ventilation load. So your ventilation load is typically handled by like a dedicated packaged DOAS unit or energy recovery unit. Yeah, so we sell those as well, and then our partners, our distributor partners like Trane, they have 3 or 4 different options you can choose from depending on the application. So when we're talking with design engineers and architects, that's one of the big topics early on we need to address is how we're going to address ventilation. So depending on the building type and the application that it serves, we'll go one route, and then sometimes we can use our units as well. But our units are limited in airflow range, so it can only go up to about 1,200 CFM of airflow. Good question. Any others? Good. All right, so let's move on to some of the regulatory and refrigerant changes. In order to help achieve those greenhouse gas goals we discussed earlier, some regulatory updates were needed on multiple facets, from minimum efficiency and rebate qualification criteria to more sustainable refrigerant requirements. So here's a nice little timeline of the regulatory changes. 2023 has already passed, right? But there's some changes that took place then between the DOE efficiency and M1 changes to SEER 2. There's also different, homes and 25C tax credit things that took place. In 2024, we were moving on to the transition of low GWP refrigerants. So UL has updated their standards to UL 60335-2-40. Previously, it was UL 1995. And that provides guidance on how to safely manage low GWP refrigerants. Along with that, the building and mechanical codes have been updated to reference low GWP refrigerants. And then from 2025, we will have to transition to a low GWP refrigerant for residential products. And then in 2026 for commercial products, which in our case is VRF. So essentially how that breaks down is January 1st, 2025 is that first phase of low GWP refrigerant. And that applies to single phase power equipment less than 65,000 BTUs. Okay? And then anything that's 3-phase power or greater than 65,000 BTUs is January 1st, 2026. All right, so let's take a look at, for a few minutes to review the basics regarding the refrigerant change, because there's a lot of terminologies here and acronyms that I'm not sure how familiar you guys are with this, but some fundamental questions. So first one here, as you can see on the screen, why are we transitioning to a new refrigerant? Well, the objective is to reduce greenhouse gas emissions to cap the global temperature increase to below 2 degrees Celsius, which is equivalent to 3.6 degrees Fahrenheit. The transition to low GWP refrigerants is estimated to reduce the temperature rise by up to 0.5 degrees Celsius, or about 1 degree Fahrenheit. To put that in perspective, 25% of the global temperature increase is avoided by just the refrigerant change. The rest will be through electric vehicles and other sectors. Second question is, what does GWP of a refrigerant represent? what is the new limit? Right? So carbon dioxide, CO2, is the base for measuring the global warming potential. So that GWP stands for global warming potential of a refrigerant. Our current refrigerant is R410A, right? Those of you who have been around the HVAC industry, we used to have R22, before that R12, right? It's changed along the way. This is yet just another transition to a different refrigerant, right? So you can see, I don't know if you can read that chart, that circle, but essentially you go back to the 1800s, with natural refrigerants, and then in the 1930s, the development of CFCs, and then 1980s, HCFCs, 1990s, HFCs, and then all these different acts, Montreal Protocol, Kyoto Protocol, global warming becomes an issue, and now in the 2010s, between Europe and Asia, we're kind of shifting our way backwards, from HFCs to low GWP HFCs/HFOs and natural refrigerants. Okay, so R410A has a GWP of 2,088, which means that it has 2,088 times the greenhouse gas impact of carbon dioxide. The new limit, defined by the EPA, requires the use of a refrigerant with a GWP of less than 700. Okay. So what are the options for replacing R410A? That's our next question. Although there are many, the main options are either R454B and R32. Mitsubishi Electric has selected R454B for the current residential systems, and for VRF as well. We'll be transitioning to R454B in 2026. As you can see from the chart on the right, there's a 78% reduction in GWP when moving from R410A to R454B. While R454B was selected as a refrigerant to use for the initial product launches, all refrigerants are being considered in the future. So, this is for the next 5 or so years, it's going to be our refrigerant. But as things change over the next couple of years, it might shift to yet another refrigerant. Who knows, right? So what's different about these low GWP options? Most of the physical properties of these new refrigerants are similar to R410A, so that's good news. The key difference is that low GWP refrigerant falls into a class called A2L, which are considered low flammability refrigerants. So let's get into that. What is an A2L? Did you say flammable? Is it safe? A2L refrigerants are considered non-toxic and mildly flammable. So the A stands for non-toxic, 2 stands for flammable, L stands for low burning velocity, meaning it needs at least 1,000 times more energy to ignite than, say, an A3, like propane, and will self-extinguish. So again, it's low burning velocity. It needs at least 1,000 times more energy to ignite. Okay, so UL. All right. So plus the L indicates that in the unlikely event it ignites, it'll actually self-extinguish, which I already said. So it is quite safe. Even then, to ensure the utmost safety, UL 60335 implemented strict safety requirements for the design and application of systems with A2L refrigerants. Additionally, all building codes have been updated to provide guidance on installing systems with A2L refrigerants. And finally, AHRI has formed a task force to ensure industry training takes place, further safeguarding from errors. Any questions on A2L?
Yeah. Leaks. Freon leaks in the system.
Yeah.
How are they addressing a chase for freon lines?
Yeah. I think the next question may help answer some of the leaks, so let's good segue right into that. That's why I like how these slides flow, because it's questions, right? Like, this is still evolving. All right, so what risk mitigation steps are required by the UL standard? Leak detection is one of them. ETRS, which is Enhanced Tightening Refrigeration System, circulation of airflow when a leak is detected. There needs to be a designation for minimum installation area based on LFL, which is another acronym, stands for lower flammability limit. And then it also, that UL standard is part of the risk mitigation steps is shut-off valves to limit refrigerant charge leakage. So keep in mind that the risk mitigation is based on refrigerant charge. So the lower the refrigerant charge, the less mitigation requirements. So essentially what that means is, the next slide, how is Mitsubishi Electric making systems easier to install? We will have built-in leak detection sensors from the factory in our future products starting in 2025. And built-in shut-off valves as required by the UL standard.
Where are those going to be?
The shut-off valves, if it's a one-to-one system like a single-zone mini-split, it's likely going to be at the outdoor unit. So because that's where the compressor is and it'll shut off. If it's a VRF system, that's where it gets more complicated, and we're still waiting for a more clear, guidance from the EPA, because you can have a variety of different scenarios with up to 50 indoor units, right? All right, so built-in shut-off valve required. All control logic will be built in for risk mitigation, such as air circulation. We're also designing our systems to have smaller refrigerant charges wherever we can, as with the same performance and efficiency. Basically, we'll have a more efficient hex design. And we are working to ensure we have similar pipe sizes as our 410A for easy replacements. Next question is, when will the transition begin? I already kind of covered this in the previous slide, but the importation of our 410A systems will be disallowed from January 1st of 2025 residential. So that date, January 1st, is basically we can't bring in new systems, old R410A systems, but anything that's manufactured before that date can still be sold through, and that's the final question there. Is there a sell-through period? And the answer is yes. R410A systems imported before January 1st, 2025 can be sold through the end of the year for new installations. On the right-hand side here, there's a couple great little facts. So let me just add some of those data points for reassurance. So please take a look at that. 2014 was the first year that Mitsubishi Electric sold its first A2L system, and that was over in Asia. There's more than 20 million systems sold by Mitsubishi globally since 2014, A2L systems. And that's either R32 or R454B. And there's, just in Japan alone, there's greater than 1.5 million A2L systems sold yearly in Japan alone. So Mitsubishi Electric is very experienced with A2L systems, and we will guide you all through this transition. It's not something new to us. It's new to the US, and we have to abide by UL and EPA and all those different, codes and regulations, but we are here to assist. All right, next slide. If I can get it to go. All right, so here's a nice timeline. We're in 2024 now. Starting 2025, our 410A units imported in 2024 and earlier can be used in new installations in 2025. And then our 410A indoor units, outdoor units, and parts can still be imported, but labeled. They'll have to be labeled by law for servicing of existing systems only. And then our 454B units will become available here at the end of this year, early next year. All right, so other questions we got. Will performance be better than the current R410A units? Efficiency improvements across the board are expected, but the specifications are still being finalized by the factory. Will the new units cost more? Well, yes, mainly due to the additional components required for safety. Just like anything else in this world, everything cost is going up. All right, so from a service perspective, regarding the transition, how long with R410A parts will R410A parts be available? We plan to stock our 410A parts and support our customers our maximum warranty offering of 12 years. How long will our 410A indoor and outdoor units for service only be available? We plan to have service only models available through at least 2025 and likely into 2026 to support our what we call goodwill replacements. Most units are replaced in the first 1 or 2 years after installation, and most units are replaced due to concessions on our part. Something that we can't establish a root cause, or we're trying to make things right. So we plan on doing that as well. Can existing R410A piping be reused? Yes, assuming existing piping are the specified size. So that's a big caveat, right? Considering that R410A and R454B use the same refrigerant oil, only a nitrogen flush is needed before replacing it with R454. Are there any differences in servicing R32 versus R454B? Right, remember R32 is another A2L refrigerant. So you'll either see manufacturers be, oh, we're R32 or R454B. Fun fact, guess what R454B is made of? R32 and R1234YF, which is what most of our cars have. I think when I say most, I think newer cars, I should say, for your AC systems in your car. That's what R454 is, a blend of those two. Okay. But the answer there, are there any servicing differences? No, service and installation of these systems would be the same. Any refrigerant-specific tools, for example, recovery tanks or charge hoses, would be different because they're slightly different refrigerants. How much of the existing system can be replaced? Over the life of the system, 100% of the outdoor units and 75% of the indoor units can be replaced before it's considered a new installation. But for a single zone system, this means that either the indoor or the outdoor can be replaced, not both, okay, for it to be considered, not a new installation. All right, so training. Will we be conducting R454 specific training? Yes, we're beginning in March, so this month, with an overview of refrigerant transition as e-learning modules and via our podcast. We have a podcast, if you've never heard of it. It's called the METUS Tech Show, if you listen to podcasts. Product introduction training will begin in the summer of 2024 as live webinar sessions, so be on the lookout for that. When will Mitsubishi's training centers be updated with the R454 equipment? We're expecting that to happen at the end of this year. And then distributor-owned training centers will be updated in early 2025. When will Mitsubishi training courses be updated for R454B? We expect that in late 2024 once the training centers are updated. Will Mitsubishi continue to train contractors on R410A? If so, for how long? Training through 2025 will be a hybrid format, focusing on both R410A and R454B. Training will be 100% focused on R454B by 2026. All right. So got about 10 minutes here. Wanted to kind of segue into what are some of our new commercial products that kind of helps address some of these concerns with the refrigerant transition. Hybrid VRF is an excellent new product. We've actually have had hybrid VRF over in Europe and Asia since 2017, so almost 8 years now. So it's not new technology. It's new to the US. We brought hybrid VRF to the US, got it UL rated and all that, and we launched it last summer. What is it? So hybrid VRF is the first and only all-electric hydronic two-pipe VRF system with simultaneous heating and cooling. So what it is it's, if you're familiar with VRF, right, you still have the same outdoor unit as you do with traditional VRF, and you run refrigerant, two pipes from that outdoor unit to what we call a hybrid BC controller, or the HBC. And that hybrid BC controller has refrigerant to water heat exchangers, so it exchanges the heat between the refrigerant and the water. Therefore, everything downstream of the HBC is all hydronic piping, okay? So it uses roughly 30% less refrigerant on average in the overall system compared to traditional VRF. And now you have the benefit of interior water lines using either copper or a composite multi-layer pipe, MLC or MLP pipe is what we call it, that can offer reduced labor and installation costs. So copper, because this is hydronics, the copper pipe is going to be your 3/4 inch copper and 1 1/4 or 1.5 inch copper. So our standard for that, we only allow brazed. We don't allow soldered copper, only brazed copper. So a little bit more of a skilled type of install. So our recommendation is this composite multi-layer pipe because it works and it's easy to install like PEX. Right? So if you're on the plumbing side and you're familiar with PEX, it's not a PEX product. It's slightly different than PEX. It's got a PERT polyethylene inner layer, aluminum middle layer, and then another PERT outer layer. So it's easy to work and cut just like PEX is, but it has similar thermal properties and expansion properties like copper. what we've learned and the benefit of having this product first launched in Europe and Asia is the first couple of years they were using PEX for those water lines. And what they saw over time is it was causing water leaks because that same set of lines going to the indoor zones was seeing 45-degree chill water and as high as 130-degree hot water. So because of that going back and forth in heating and cooling, the pipe was expanding and contracting, therefore it was causing the PEX to crack. And it wasn't, the hangers and the spacing, the PEX just wasn't able to handle, and it was cracking and causing water leaks. So they found this multi-layer composite pipe that similar installation practices like PEX, just has better properties similar to copper. So that's what we're bringing into the States to sell with this product, but it's a great offering, and it helps with reduced labor and installation cost. All right, so what are the advantages? Just a high level. The biggest one is no refrigerant in the occupied space. Okay, we're kind of future-proofing due to some of these refrigerant changes coming. There's also a little bit better, tighter temperature control. The indoor units are going to be slightly quieter. The efficiencies is similar to VRF. It's going to be a little bit less because you get that refrigerant water heat exchanger, so you lose some efficiency there, but it's still highly efficient. Controls are the same. So on the control side, traditional VRF controls, none of that changes with hybrid VRF. And then the other benefit is what I just talked about with the multi-layer composite piping, some savings on the install side. Also, operating pressures on these things is anywhere from 14 to 27 PSI. So compared to traditional VRF where you're 600 PSI, very, very high pressure type of system, hybrid VRF, downstream of the HPC, I should say, that's all anywhere from 14 to 27 PSI, depending on elevation, things like that, where you are in the country. All right, so the initial lineup of HVRF, again, you get the same outdoor unit, either air-cooled or water-cooled, ranging from 6, 8, 10, 12, and 14 tons. So this is all three-phase power, right? And then inside the building, you have your main hybrid BC controller, either 8 ports or 16 ports, and then you have subs. If you need more zones than 16, you can add a sub. And then these are the initial indoor unit styles. We have our horizontal ducted medium static indoor unit, our two different indoor units, the 3x3 four-way cassette and the 2x2 four-way cassette, and then our wall mounts. To wrap it up with hybrid VRF, in general, commercial applications with small interior rooms or zones will benefit the most from using HVRF. Things like your hotels, hospitalities, higher education, student housing, multifamily apartments, senior living, assisted living facilities, commercial applications where you have a lot of smaller zones inside the building is where we'll see this really take off. Not that you can't apply it to a larger classroom, but this is where we've seen HVRF be successful over in Asia and Europe, and that's what we think will happen here in the States as well. All right, one last product that we launched here also earlier last year. It's called Heat2O. Heat2O is a domestic hot water heat pump. So again, not HVAC or on the plumbing side of things, but it's a commercial grade domestic hot water heat pump. It utilizes CO2. So remember we talked about GWP. That has a GWP of 1, right? So that's a natural refrigerant. It's a high pressure refrigerant. So what it is it looks like your VRF condenser, right? From the outside, but it's truly a commercial heat pump for domestic hot water heating. It can produce high temp hot water up to 176 degrees. It has a high efficiency COP of up to 4.52. It's operable at low outdoor temperatures, not something we need to worry too much about here in Florida, but 100% heating capacity at 36 degrees outside and 50% heating capacity reduction at -13. It is variable capacity, so it uses our inverter-driven compressor. It is also a single-pass heat pump domestic water heater. We have QHV, that's just a nomenclature, the model. There's 3 capacity settings. The default is that first one, the 40 kW, which is roughly 136, which is about 11 tons. You can actually pipe these in parallel, so you can have up to 16 units being the same system, which is essentially 640 kW. So sizing and all that is a little bit different because it's all driven by, the domestic hot water demand in the building, right? So because it's a single pass heat pump domestic water heater, they're most efficient at a higher delta T, delta T meaning the entering and leaving water temps. So for that reason, it relies more on thermal energy storage and less on the actual generation of heat. So we typically will design this using less outdoor units, less heat pumps, and more storage tanks. So storage tanks are typically sized to handle the bulk of the peak demand load in a building for domestic hot water. And then it uses the heat pump, domestic water heater, the Heat2O, to replenish the storage following like a peak demand or something like that. So they're designed, they're sized to run anywhere from 16 to 24 hours a day. The storage tanks are typically lower cost than the heat generation. And we will provide assistance in sizing these systems. But here's a nice schematic of what it looks like, right? You got a primary side, which is the heat pump outside the building. And then you have all the way up to that secondary heat exchanger inside the building. And then on the secondary side, that's the other half of the secondary heat exchanger, the hex, as well as the storage tanks and the recirc pump, things like that. And then we also have our swing tank, which maximizes the efficiency of this type of product to recirc the water. So here's another graphic of that schematic in a more diagrammatic instead of a pretty picture like this. You see these on drawings and get a better idea of how everything flows, supply and return, things like that. So Heat2O is great and ideal for large domestic hot water loads, right? Again, student housing, higher education, apartments, multifamily, hotels, hospitality, senior living, assisted living facilities, 24/7 occupancy type buildings. And again, we've launched this product in a limited capacity up in Washington State and Oregon and Northern California and New York and Massachusetts. And we're starting to open it up to other states. We wanted to, it's a new product for us. We're mainly HVAC focused, and this was our first plumbing focused product. So we didn't want to get, too crazy with this product, but we're expecting by the end of this year it'll be available to the rest of the states.